video is on atomic radius. Now, atomic radius is just basically the size of an atom. And if you think of an atom as a sphere, radius should make sense. Radius is going to be the distance from the center of a sphere to the outside of it. So there is a trend on the periodic table for atomic radius. The trend is that within a group, so we're talking columns, the atomic radius will increase as you go from the top to the bottom. So as you go down a group, the size of the atom gets bigger. Within a period, so across the rows, it increases from right to left. So you can see a graph here of different atomic radius by atomic number. So we've got on here our first two elements. We've got hydrogen and helium. And as you go, hydrogen is here, helium's here. It's not a great trend, but as you look to the next one right here, this would be lithium. And then next to lithium is beryllium. And as the atomic number gets bigger, you can see the size gets smaller. So what that's saying is within a period, right, as we're going down here, the period you're going to the left, which means it's decreasing. Okay, I do the trend listed as increasing. So you look here is kind of a periodic table with kind of little visuals of size-wise. So you can see as you go to the left, the radius tends to get bigger. Now, these aren't perfect trends. What I mean by that is it's not always going to be this case. But they tend to get bigger as you go to the left. They also tend to get bigger as you go down. So basically, if you look at the periodic table, francium is going to be the biggest atom. It's the furthest to the left and the furthest down. So, question for you. Why is atomic radius larger going down and to the left? Pause the video right now and just think about this answer. So the reason the atomic radius is bigger as you go down and as you go to the left is as you go down, you're increasing and adding an energy level. So hydrogen has 1 energy level. Lithium has 2. Sodium has 3, and so on. As you get more energy levels, you're getting further away from the nucleus, so you're getting a bigger radius. So why is it bigger as you go to the left or smaller as you go to the right? Well, as you go this way, as you go to the right on the periodic table, as you go towards the noble gases, you're getting more electrons. So you think, okay, well maybe that means it's going to be bigger. Well, no, what's happening is you're getting more protons in your nucleus as you're getting more electrons surrounding that. Well, protons are positive and electrons are negative. Positives and negatives attract to each other just like opposite ends of a magnet. So as you get more positives and more negatives, you get a stronger attraction. So it's like having a stronger magnet. So it's actually pulling these electrons in tighter. So that's why as you go to the right, they get smaller. So let's do a couple practice here. Zinc versus aluminum. Which one is smaller? So I said they get bigger as they go down and to the left. So this is bigger. They get then smaller as you go up and to the right. Okay, now this is the trend. So if we're comparing zinc and aluminum, zinc is here, aluminum is here. Which one's smaller? That would be aluminum. Further away from francium, you can think of it that way. Then we've got calcium versus potassium. So here's calcium and here's potassium. Smaller is going to be further away from francium, so further to the right. So calcium would be the smaller